Hello students, here's a good news for you all. You can now watch my videos in Hindi also. All you have got to do is go to the specific video, click on settings, next click on audio tracks and then change the language settings from English to Hindi. You now have the dubbed version of this video in Hindi. Hello students, welcome back. Let's take up another question. This time it's from magnetic effect of current and the question goes like this. State Fleming's left hand rule. Use this rule to determine the direction of force applied on an electron entering a uniform magnetic field as shown in the figure. Alright, so here we have been given a figure in which there is a magnetic field and the magnetic field direction is from the left to the right. As you can see over here, then we have an electron which is going in the upward direction, that is perpendicular to the magnetic field. Now we know that this electron will experience a force when it passes through this magnetic field. Now as a result of this force it will be deflected. Now in which direction it will be deflected, we have to find it out using Fleming's left hand rule. So before finding out the direction in which the electron will be deflected, let's first understand what is Fleming's left hand rule. So as I've just told you, Fleming's left hand rule helps us to determine the direction of force on a current carrying conductor placed in a magnetic field. It means that if any conductor which is carrying current is placed in a magnetic field, then this current carrying conductor will experience a force and it will be deflected. Now in which direction it will be deflected, that will be determined by Fleming's left hand rule. So the Fleming's left hand rule states that if you extend your left hand's thumb, forefinger and middle finger perpendicular to each other with the forefinger pointing in the direction of the magnetic field, the middle finger pointing in the direction of the current, then the thumb will point in the direction of the force or motion on the conductor. So if you stretch the three fingers, that is the forefinger, the middle finger and the thumb of your left hand in three mutually perpendicular direction, then if the forefinger represents the direction of the magnetic field and the middle finger represents the direction of current, then the direction in which the thumb will point will represent the force acting on the conductor. Now there is one important thing which you need to remember here students, that the current which we are talking about here is the conventional current, that is the current which flows due to the flow of the positive charges, and this current flows from the positive terminal to the negative terminal, and the direction of this current is opposite to that in which the electrons flow. That is, the conventional current is opposite in direction to the electronic current. So in which direction the electrons will move representing the direction of the electronic current, the conventional current will flow in the opposite direction, that is the direction opposite to which the electrons will flow. So here we will always consider the conventional current as the direction of current flow and not the electronic current which is due to the electrons. So now let us tally this with a diagram that is given in the question. So as you can see here, the magnetic field is pointing from left to right. So we have aligned our forefinger so as to point in the direction of the magnetic field, that is from left to right. So this is the magnetic field. Now the electron is flowing upward. So the electronic current is flowing upward. But as I've told you just now, we'll take the direction of the conventional current as the direction of current flow, and the direction of conventional current is opposite to that of the direction in which the electrons flow. So the current is flowing in the downward direction. Hence I have pointed my middle finger in the downward direction. So now as you can see, the forefinger is pointing to the right, the middle finger is pointing downwards. Now we see that the thumb is pointing outward, that is out of the plane of paper. So the direction in which the electron will be pushed is outwards. So that was the answer to this question. I hope you've understood it. If you found this video helpful, please do like this video, share it and consider subscribing it if you are new to this channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.